So we're going to talk about Azure All-Up Database Platform. Earlier, I had a talk about Cloud Adoption Framework. That was the first talk of the day. Just a brief introduction. My name is Sumit Sengupta. I'm a cloud solution architect with Microsoft, a partner organization. And this is what pretty much we do on a day job, basically architect solutions and data and AI platform for our customers and partners. So the data landscape is huge in Azure, right? So what we talk about, and they're doing different things. So on the left-hand side, as I keep highlighting things real quick, what are those tools and what do they do? Azure Data Factory, Import Export Service, SDK is, of course, how you deal with it. CLI is how do you interact with the Azure with the command language. Data Factory is a tool to do essentially ETL, ELT, and also run SSIS integration packages in cloud. Import Export Service is one way, remember, one way to get data into cloud. Moving on to the database platforms, we have this relational databases and NoSQL databases. Now, there is only part of it. We are not showing all of it. In fact, in this picture, we're not showing PostgreSQL and MySQL database and MariaDB that we have, and we'll talk about that a little bit in this talk. Of course, we have many flavors of SQL running in Azure. We'll talk about those. Also, NoSQL databases, Cosmos DB. These two things, we'll go a little bit deeper into discussions. Then we have SQL Data Warehouse, the MPP engine. This is the Synapse Data Warehouse, the newer name now. It's going to be all inclusive. It's not out in GA yet, but when it comes, it's going to be running big data around your SQL engine as well as a Spark engine together. So you could literally have the same data set residing in a blob storage, and you can query using either SQL or either Spark, either out, and you can have those compute engines, the SQL as well as Spark, spin up and spin down anytime you want on your own. Obviously, we have the storage layer, blob storage, data lake storage. To be honest, the storage layer is fundamentally where data gets stored, even if when you create a resource like Azure SQL Database, not for Cosmos DB, though Cosmos DB is a different animal. Data Lake Analytics, we don't have it anymore. We do have Data HD Insight and Databricks. So this is a way of running Apache HD Insight, like if you want to learn big data clusters, like Apache Storm, Apache Kafka, Spark, on your own, versus if you want to run Databricks Spark, that will be this. For IoT streaming data, these are the entry points. So you when you have a when I say streaming data, it could be really any factory in IoT, but it could be also be machines. It could be also internet traffic. So data coming into Azure through these two, IoT Hub or Event Hub. And also we have Kafka, open source Kafka, if you would learn more of a Spark open source background. Up next, we have Stream Analytics, HD Insight, and Databricks. So Stream Analytics is like when you get the streaming data in, Azure IoT Hub and Event Hub is the entry point, and then Stream Analytics kind of processes that data, do some kind of massaging, just kind of very quick query on the streaming data as it comes in before the data gets written into some kind of permanent storage, which could be either relational, non-relational, or flat storage or anything. Right? Talked about that already, so not going through that. Analysis services in Power BI. So the same thing that you are used to doing in a SQL on the relational world, you can do it on cloud as well. The Power BI is for reporting, analysis services is of course for creating your bigger models. Azure Machine Learning, Memo Server, Databricks, if you would like to do machine learning data science projects on a PaaS platform in a cloud. Bot services and cognitive services, some of the AI services, but they're all connected together. So we really don't talk about just one without the other. And then you have Azure Search. So the search is our way of doing search across documents or search across intelligent search. So think of it like a text search. Think of it like AI-enabled search, right? So I can look for specific pictures, specific tags in documents. Data Catalog is coming up with this new version very soon. It's called Azure Data Catalog version 2. Underneath all of that is the backbone. So ExpressRoute is the dedicated connection network from your data center to cloud. Active Directory, of course, our authentication IDs manage. Network security groups is essentially firewall. Key management service is how you manage your security secrets, passwords, etc. Operation Management Suite, the name kind of says it. Azure Functions is serverless. Visual Studio is, of course, a tool. So if that's the data landscape, how does the big data landscape looks like? The big data landscape looks like same thing on the left-hand side, so I'm kind of not repeating that. Some of these within that, the HD Insight, Databricks, machine learning survey, those are the stuff that we talk about in the big data itself. I got a couple of decision structures. Now, don't think this is the absolute way to go, but this is like one nice way of looking at it. Okay, if I have some data to store in Azure, what are my options, right? So I'll kind of walk through this flowchart because it's kind of really simple. So if I have a data set, my first question is that, do I need a compatibility with some existing platform, right? Do I need a compatibility with any one of these on the left-hand side? So for example, if I have a MySQL application, LAMP structure, I want to move them to cloud. So if I need MySQL, well, we do have an offering for MySQL database PaaS in Azure. Similarly for PostgreSQL and MariaDB, exactly same questions. Is it an existing MongoDB? Is it an existing Cassandra DB application? So if there's any of these two, then we can move to Cosmos DB with Cassandra or Mongo API. By the way, if you do have a question, feel free to throw it on the chat window. So if I don't have to deal with a compatibility question, then I'll ask myself, is it a relational data? Yes, of course, you can go SQL. By the way, if it's a relational data, to be honest, you could also go to MySQL and PostgreSQL or MariaDB. That works as well. If it's not, then is it a semi-structured data based on read? So it is something like a streaming data, like real-time data that's coming in that needs to be ingested at a very high speed. And when we are writing at a high speed, we also get a good read performance at the same time. Now, as people who have worked on engines and databases that know that typically you design your applications and databases, well, databases to optimize for either reads or write. Here's an engine that can do very efficient write as well as very efficient read at the same time without any change. Then, if none of this is true, you're saying this is an SMB. Okay, go to Azure Files, archive for blob storage, index data. We talked about that, Azure Search. So think of it like an intelligent search by semantics, by words, by even AI. So I'm looking for certain specific pictures. I give it a description. I can create my own artificial intelligence model and feed it to the Azure Search. If none of these is true, then is it a time series data? So if I have just data that's coming in time series events and I just don't want to throw somewhere, it will be a time series insights. Not in this picture is a thing called Azure Data Explorer. So if any of you have used ADX, that's a resource where essentially you can store a whole bunch of chunk of data and you can just do analysis on your existing data. So if you don't care about like relational versus non-relational, if you have a bunch of chunk of data that we just want to throw and do query, Azure Data Explorer is your way to go. Data Lake Store and blob storage are kind of the blob storage. They're kind of same thing, to be honest. Data Lake Store is under the cover, is essentially blob storage, except some extra features baked into it and a little bit of tiny cost. Those extra features are one for security at a hierarchical level. So for example, you can create folders and subfolders and you can have security at different level, just like Unix directories in POSIX or Windows folders. And also you can treat each one of the objects atomically. So essentially you can find out like number of files, you can do a bunch of file operations versus blob storage, which is true for Azure blob storage or any kind of blob storage, to be honest, in any cloud is basically a flat land of storage, right? So once you explore the storage questions, someone is requesting control, I guess. That's okay. And then the next question is it a graph data or a transient data? If it's a graph type of database, we got Cosmos DB, the same Cosmos DB we talked about here, has a graph API. And then is it a transient data? We do have a managed Redis service in cloud. So the big thing to note is that in here, all of them are PaaS services. So really not you're managing any of those services, you're not installing or backing up or any of that stuff on your own. Okay, if I can go to the next slide, come on. There you go. So here's an example of another decision chart of data migration. Like when I'm migrating my data from on-prem to cloud, what are my, like, how do I do it? Like, what is my path? Now, remember, this is just in this slide, what we're talking about is just the mechanics of choosing, well, mechanics are two things. One is the target. Well, actually, only one thing. I'm sorry. So we're talking about is what is going to be the target of the Azure side. So my workload, do I need control of the database or host OS, etc.? Do I really need to have database in IaaS environment? Of course, I can spin up a VM and install SQL or Oracle or Cassandra or Mongo, anything I want. Though the use cases for those IaaS are usually are when you need something unique, like you need an older version of software, or you need a very large database that we don't support in PaaS, for example, or something like a data platform that would be like we don't have it in the past, maybe, right? There's a very rare cases, so this is a very, very rare situation that you go. If no, then you choose on the database type. The first thing you ask is it relational? Yes, relational. Okay, fine. Is it a SQL? Yes. Then you got a whole bunch of options in SQL. We'll spend, I would say, 10 to 15 minutes, 10 minutes on that on the SQL for this. So I'm going to skip in that. If it's not relational, then we go to MySQL, PostgreSQL, or MariaDB. These are the three open source databases that we have currently running in Azure. And these are, by the way, pure native open source database, meaning you just have MySQL running anywhere else. You can just plug it into Azure. We're not changing the code. We don't have any specific MySQL variant that is not open source. For caching, you got a need for Azure Cache, Redis Cache. For Cassandra columnar structure, you can do to Cosmos DB. We kind of discussed that in the last slide as well. For column family, you can have HBase and HD inside. So this is our big data open source cluster. For analytics, if it's an unstructured data, which is just throw it in a data lake storage. If it is structured data, you can have throw to Synapse Data Warehouse, which is the new name for SQL Data Warehouse. For search, we talked about Azure Storm Search, also time series, talked about time series insights. So in the relational world, if we're just now going to dig down into some of the database platforms we have, we got a choices of Azure SQL Database, Data Warehouse, and Data Warehouse is, of course, MPP. Then you got PostgreSQL, MySQL, and MariaDB. Now, these open source databases are, again, I said, this basic open source that we have. They have intelligent advisors and tuning and monitoring all baked into it. So if a query runs slow, it automatically gets reported. And it will automatically give you advices that, hey, this is the thing you want to do. You want to throw an index here, right? It's flexible in the sense you can scale the size of the database. So from 2 code to 4 to 8 to 16, you can just with a slide of a bar, with a command line, with a PowerShell script, you can change it. Of course, trusted is HA, DR backup is all baked into it. Now, it's running underneath an Azure storage. So under the cover, at the end of the day, the data is actually stored directly in Azure storage, which means you got the global presence. You can have it in any of the 54 regions in Azure. These are some of the tools that would deal with the data services. I'm not going to talk about that because we kind of talked in the second slide already. So now we kind of go into the SQL. So when you have to have SQL databases in Azure, what are my options? And kind of how do I decide what do I want? So your first thing is that I want a virtual machine, right? And the reason I want a virtual machine, this could be a case, and if you want to go to Azure Virtual Machine, is you want to manage the hardware. You want to have, like I said, older version of SQL. Maybe you want to create things that are not available in past, like you want to create your own file groups. You want to have your own RAID group. You want to have extreme performance, like 50, 60,000 IO per second, something like that. You may want to plug it with your existing HADR solution. So those are the use cases for IaaS. This is rarely used. Even if you do use that, you should go to a route called resource provider. In other words, even if you install SQL on your own in a VM, if you list it as a resource provider in Azure, what you get is you get a benefit of automatic patching, automatic management. So even if it's in VM, your SQL gets patched and managed automatically. And also you get license compliance automatically from Microsoft. Then the next option would be I want a SQL server. So I'm moving from on-prem to Azure. I don't need to have my own VM. Give me my options. Your first option, this is actually the recommended normal option that we offer for most customers, like to try this thing called SQL Database Managed Instance. It's about a couple of years old. It is wildly popular. Essentially, you get your own database in your dedicated virtual cluster. So think of it like having an always-on availability group cluster in SQL, and that's available only to you, no one else, and it's only on your own network. So it is very secured by design. You can't access it from outside the network. And finally, you want a third option, like, oh, I don't care. I don't care about all of that stuff. Just give me a database. Right? Just give me a place to store my relational SQL database. And then you have the regular PaaS database options. And over there, you got some variant of these databases. You got single, elastic, hyperscale, and serverless. So we'll talk about a little bit more detail on those. Single is just creating a single database, like it says. Elastic is a way to combine resources together. So if I have like 10, 20, 30, 40 databases, I would like to share the resources, share the cost as well. Elastic is a way of creating elastic pool, putting them all them together. So I share the resource, I share the performance, I can do anything I want. Hyperscale is a way to go for very large databases. So if you have today, if we have a SQL database that's over 4 terabyte or 8 terabyte for SQL database managed instance, and 4 terabyte for Azure SQL DB over here, you can't have it because that's the size limitation right now on the PaaS offering. So hyperscale, it's a very different architecture. We'll talk about that. It actually lets you go move your SQL database to up to 100 terabyte. Actually, there is no limit on the storage how it can go. And serverless is actually one of the newer offerings we have. In that your SQL database engine can be paused. So essentially, if you have a use case where you have a SQL database that you need for, let's say, a few hours a day, or it's sporadically used, and you don't want to pay for the compute engine all the time, you go in a hyper serverless route where you can pause the SQL engine and you pay only literally by the second. The billing is by the second, only for the time that the engine is running. And if you are not doing anything, the engine will automatically pause itself. So your compute charges stop. And then as soon as you start the request to the engine, it will wake up. The downside, it sounds like too good, so why don't I do it for all the time? Is downside is the per second billing cost is a little bit higher. So if you don't really need the database to say, let's say for 15 hours or 12 hours a day, it doesn't make sense to keep waking up. It actually ends up paying more. So some of the SQL database options I talked about, single options, elastic pool, if you share the resources, managed instance, if you really want a secure environment, if you want an own cluster. Think of it like your own cluster where you can create multiple databases. So you don't get billed for separate databases together because you're getting billed for instances. You got X amount of storage. It's up to you how many databases you want to create. All right, so SQL is everywhere. These are some of the options you have. Of course, you can have SQL Server 2019 with the big data cluster. This came out last year. You can run SQL on Linux. You can run SQL on containers. In fact, some of these you're going to see when we have Synapse GA most likely this year. Then you have SQL on Kubernetes. So database built-in HA, baked in Kubernetes. Of course, talked about virtual machines, talked about managed instance and SQL databases. And here's a new thing that's in preview called SQL on Edge, which is really, really cool technology. Essentially, you can run a SQL database on IoT edge devices, an ARM chiplet. Like you can do IoT right on the edge itself, even without getting connected to the cloud. So if you are interested, you can sign up for these. I got quickly, I got about 10 minutes. So I go quickly through some of the benefits of SQL managed instance. In fact, I can see it all over here. So first of all, like I said, the managed instance is probably our most offered and most popular offering in SQL. In it's a fully managed service. So it's based on the same surface area as a regular SQL database, meaning if you have a SQL database on premise, almost all of the features that you can do on that SQL server on-prem is something that you can do in managed instance, okay? It's fully fledged SQL with nearly 100% compatibility with on-premise. That's what it says. It's contained within the VNet. I talked about security, so the managed instance is only accessible from the same network. The VNet where the managed instance itself resides. You can't access it from outside. So Azure being a public cloud, no one else can connect to it unless you're connected to the network. And there's a new pricing options for that. So kind of talk through, let's go through these slides in the interest of time. Okay, let's do this. So how do I migrate my database from on-prem to cloud or from another cloud to cloud? There's a whole discussion and training on these things. But in really short, if you have on-premise databases, no matter whether it's relational databases like SQLs and Oracles and MySQL, PostgreSQL, or non-relational MongoDB, there are tools to do what we call assessment, to connect to the on-premise resources and find out what we have. So SSMA, SQL Server Migration Assistant tool, has been existed for, I think, about 15 years or something. It's been an old tool. But even beyond that, we have a thing called Data Migration Assistant. So Data Migration Assistant is actually a binary, like a Windows install, that you can run to assess your on-premise SQL environment. So things like, if I move my database to cloud, am I going to lose some feature? Is there going to be some kind of feature that behaves differently in cloud than in on-premise or this particular version? Is the size a factor, right? All of these, this assessment tool will do. And once you see that, the tool will also tell you like what's the remediation. So I may have a data type, say in a database that's not supported in SQL Cloud, so or doing some kind of query that may not work. So how do I remediate those? Then we have a service called Data Migration Service. This service runs in Azure Cloud, and it's free. This costs nothing. The whole purpose of this service in Azure is to help move your database from on-premise to cloud. So think of it like a backup restore service. So all it does is it takes a backup of your existing database, puts it into cloud, and from there it will restore to cloud. You can do it in an offline mode and an online mode. Online mode meaning actually it will set up some kind of replication. So from your on-premise to cloud, you set up the replication and get the replication working. And then when you are comfortable and free, maybe a downtime, a few minutes you can take, you simply flip the replication over to cloud. So that's how easy it is for the migration. Now I talked about SQL, but you can actually use this data migration service to move to, for example, Cosmos DB or PostgreSQL or MariaDB as well. And all of these are documented very well to a website called datamigration.microsoft.com. In fact, I should probably type it right here. Datamigration.microsoft.com. There you go. So check that website out. It's a very wonderful place to talk through about the mechanics of moving databases. We talked about cloud adoption framework early in the morning. That's our strategy, planning, etc. Here we're talking about migration phase, the execution phase. Okay, so there is another tool called Database Experimentation Assistant. This is also SQL specific. The purpose of this tool is to basically run a workload capture on your existing environment and then replay that workload on your cloud database to see how it will perform. So even if, going back to my previous slide, even if you know your source and you know your target where you're going, the next question you might ask, what size of environment do I need to cloud that will perform well, right? So this tool for SQL, again, this is SQL specific though, will tell you what size will it perform well. For NoSQL and MongoDB, we have other tools that we're going to talk about. Database Experimentation Assistant. Okay, I'm not going to go through the connection of managed instance, a little bit more details on managed instance itself. Talk about hyperscale. So this is a newer offering of SQL database PaaS offering in the cloud. This is GA, so you can get it right now. The key benefit here is that there is literally no limit of how big your data can be. So I'm saying here in this message, it's going to be up to 100 terabyte. But this kind, there's 100 terabyte is not a hard limit. You can go beyond that. The other thing to understand, without going to very detail into this slide, is that your architecture is the 3 tiers. You have a blob storage. This is where eventually at the end of the day, this is where all your data lands, the storage tier. Then you have a cache tier. So this is your cache file. So this itself is SSD BAT. So if you can see, resilient buffer pool extension data cache. So basically your buffer pool. So from the top, if you look in the very top here, this is where compute engine is. So when you connect to the instance for your read and write operation, you connect to this instance. For your read-only operations, you could connect to any one of these three operations. They themselves have kind of SSD BAT, so your data is probably cached here itself. If it's not cached here, then it will be in the cache layer over here. This is where your data is 100% cache. In other words, it's not going to go to the storage layer at all to get your data. So it's extremely performant. It serves the very large databases, but the key thing to understand is this is a SQL single, isn't not an MPP. This is not a data warehouse. This is an SMP process which running on a very, very large databases. Okay. Another key new thing we talked about is Azure. Oops, I'm about not too much time left. SQL Database Edge. So this is a small footprint database, SQL database that we can run on edge devices. The engine can be less than 500 megabytes. So the use case would be time series, could be IoT, could be analytics. You can run IoT and machine learning right on the edge device itself. This is in preview and this could be GA soon. Now we're going to leave to SQL to talk about two other different database types. One is in the relational world. One is in the relational world about MySQL and PostgreSQL databases. So this is where I'm just showing the connection, how it works for your client on the application side, connects to a gateway, connects to the server, and the database is always 3 copies of storage over here. Your container can flip very easily. So I can lose my container if there's an outage or downtime or something, another one would come up. We give you 99.99% SLA on this OSS database, which is MySQL and MariaDB as well. And next up, we're going to talk about Cosmos DB, and that's the last of the database type. Oh, I'm sorry, this is a PostgreSQL. So for PostgreSQL, we offer it a hyperscale. So this is a different type of hyperscale than SQL hyperscale, in the sense that it lets you scale your database to very high storage for sure. But over here, we have a SQL engine on all these nodes. And the way it works is kind of master slave. So if you're familiar with big data Hadoop clusters, it's the same way with hyperscale Postgres database. You have a master node, you have a worker node, and data is attached directly to the worker node. So this is a little different from SQL hyperscale, but this is an offering we have, this hyperscale that is only available right now for Postgres, not for MySQL yet. Finally, we'll talk about Cosmos DB. Cosmos DB is our relational databases. It could be, think of it as MongoDB, think of it like Cassandra, think of it like a graph, think of it like all of that stuff. It provides you a lot of benefits, which is literally unprecedented in the industry. For example, you can store your data to literally petabytes. There's no limit how big you can go, how much transactions you can go. There is no limit either. You can have different consistency models. So you can have strong consistency, which is typical of transactional databases, versus eventual consistency, typical of NoSQL databases. But you can offer consistency levels in between. This is unique. This is no other cloud NoSQL databases in Amazon or Google offers that. So this is really cool in Cosmos DB. The other thing that is cool is you got guaranteed SLA. So the performance, like every read and every write, is going to be like less than 10 milliseconds. That's guaranteed by SLA. If we don't meet the SLA, essentially get money back from Microsoft. So with that, that's the end of my talk. I think it ran a little bit 2 minutes over. The next talk will be with my colleague Bruce Sebo. He'll talk about cognitive services. Any questions?